This is the second chapter on kinematics. In kinematics, I told that to study the subjects, I need to discuss about some more topics. So first I will do the recap of the thing that I've taught. That is the first definition of kinematics I've taught. That is nothing but the kine means motion, and matics means the mathematics. With that, so is altogether any object which is in motion, the relation of their different you can say the parameter of motion being taught in terms of mathematics or in terms of equation. These are the this is the chapter which is covered in kinematics. But thing is that we will not consider the reason of motion. So that is excluded of motion. So that is excluded from the subject kinematics. So this is the definition. Then after we told that there are 2-3 subjects that has to be taught. One is equation, because this needs to understand equation to build relation between the parameters of the motion. So we have taught that, we already learned. This is kind of linear, and this is kind of linear and quadratic. So these are the two kinds of equation, and different problem we have sorted out. That is enough to understand the relation between the parameters of kinematics. Second one is the reference frame. We taught about the two-dimensional reference frame and three-dimensional. That means where x and y are there only. This is in two-dimensional axis system, or x is there, this one, and y is this one, two-dimensional. And three-dimensional x, y and z will come, that we call Cartesian coordinate system. So this is basically when we study in space, and this is basically we study in plane. Okay, this is 2D system, this is 3D. So this is the basic concept of reference frame. In this subject in kinematics, we further studied that reference frame could be in rest or in motion. So how they are behaving when this is in rest and motion, that we have discussed. Further, one more subject that is needed to be considered, that is your scalar and vector. So this is the another subject which has to be taught, and in that till now we have studied what is scalar and what is vector. Scalar only concerned with magnitude, and vector is magnitude as well as direction. So where there is a need of describing direction, that comes under the vector. So for example, we can take that mass is a scalar quantity, where mass we can say 2 kg. So it doesn't need to describe any direction. Whereas if I say the velocity, here velocity is a vector, where it is represented, let's say 3 meters per second, then I have to describe the direction of that. Let's say it is east. So that velocity has to be defined with the quantity and the direction. So basically scalar and vectors are the physical quantity that I have told already. This comes under physical quantity. Physical quantity is that which can be the quantity which can be measurable, and it measured in the terms of numeric value and the unit. This together will make the physical quantity. So any numeric value, let's say that I have told, this is numeric part, and unit, that means the kg. Kg is universally understood by everybody. So if this comes together, this will be the physical quantity. Now any physical quantity are of two kinds, scalar and vector. But you can see this only this is not the only that will describe any physical quantity, because vector needs to have direction. So here, even though this also comes under the physical quantity, it needs to have direction. So there it differs from the scalar. Scalar only need the numerical value and the unit. So further we'll look into the difference of a scalar and a vector, because we have broadly understood what is scalar and vector, what is the difference behind. So if I particularly take the difference, so that scalar, you can see it is numeric, it has to have numeric value, okay, and vector also have numeric value, this is must. The second thing that is not in scalar, it must have defined direction, or else if I say the speed is a scalar, that also denotes by, let's say, 3 meter per second, but this differs from the velocity in the sense that it also can be defined at 3 meter per second, but after that it has to be supported by a direction, that 3 meter east, which way, then otherwise if it is nothing set, that we will call this is a scalar quantity, that is speed. So there it differs. And the third and fourth, the most important is that if vector must be a vector, even though it has carrying these two character, we cannot say this is a vector unless and until it follows the vector addition rule, addition law or rule, you can say. If it follows the third one, then only you can say the physical quantity have is a vector. So vector must have these two, and this is necessarily be there. This is necessarily be present. It must follow the vector rule or vector addition rule. Okay, so now take an example to support this part when we say that it must follow. Now say if there a vector, let's say electric current, if I take electric current, if I take, so the electric current have directions, because when it is flowing through an wire, it must go along this way according to the voltage difference. If the voltage difference here, this to this is positive, so then current will flow this way. So it must have some direction. But even though it is not a vector, it is a scalar, we consider it as a scalar. But how come it is a scalar? Because if I take two current flowing through, it is coming through some wire, this is the input current, let's say this is 3 ampere, let's say 3 ampere, this is 5 ampere. Now when it is merging and flowing through this path, the total current is being added. This is only the algebraic addition will follow this rule. Even we do that, we will reduce the angle also, it doesn't changes. If say that angle changes 3 ampere, 5 ampere, this angle changes, even though the ultimate current will be 8 ampere, there will be no change. So this does not follow the rule of the vectors. So vector addition must not be added as an algebraic addition. So this is the other characteristic. Vector addition must be as a scalar. The addition follows algebraic rule. Algebraic rule. I mean to say, if we have 3 kg of rice and 4 kg of rice in our bag, now if the total rice has to be counted or be measured, then we directly add 3 plus 7 kg of rice, we can say, together in the bag. So the scalar is a algebraic summation. It doesn't need any variation. Whereas if I give you an example, let's say some particle is moved or some ball is moved by 4 meter first, then it is followed, then again it is being pushed and followed 3 meter path. Okay, so now for this case, if it is denoting, because this is displacement and displacement is a vector quantity. Now from the starting point to the end point, the total path moved is 4 meter plus 3 meter. So this is 7 meter. It is very easy to calculate. By seeing it, you can assume that this is nothing less than the scalar calculation, because it is only be added as we do in algebra. Okay, but let's say if something happens that some ball is pushed, the same ball is pushed first and it gone 4 meter this way, then after some force added and it is moved this way 3 meter. Now what would be the displacement? So as per the displacement definition, we know the displacement is the shortest distance between start and end point. So displacement is the shortest distance between the start. So this ball has started from here, this is starting point, this is the finishing point. If no force is further being applied on that to move further, so if this is the final point, so the starting point and the finishing point, the distance is it will be shortest if I join these two terminals, the starting point terminal and the final terminal. Now this distance cannot be the same as this total together. So what is this distance? Now if say this is the resultant or the sum of these two vectors, this is displacement, this is vector. Now adding 4 plus 3 here, I will get something which is equal to, as per the Pythagoras formula, I will get 5 vector and the direction will be different. Okay, this is vector. So here 4 plus 3 together I am getting 5. Now assume some other case where this total phenomenon changes. The first push this way moved 4 meter. Now from here another force, it has caused to move 3 meter this way. Now what is the ultimate distance between this? This will be 4, because this is vector. If I add with the 4 and 3 meter, that will give you 1 meter displacement. I am not considering the sign right now. I am just considering the vector. If vector this displacement, this is denoting a displacement vector, this is also displacement vector. So two vectors adding together, I am getting some result 1 mm, because ultimately the difference between the final and the starting point and the final point is 1 mm. 1 meter. So you can say the different result is coming due to the orientation of the the motion. That means first case it has moved in the same direction, second case it has moved in right direction, third case is moved 180 degree opposite. So that means for a vector the sum is not as good as the scalar one. It cannot be added to get the result. This needs to have something more. In this case you can say for first case the motion between the two vectors, this is 4 vector, this is 3 vector, they are aligned in one direction. So that means the angle between them is 0 degree. In this case it is 90 degree, in this case it is 180 degree. So when angle between the vectors changes, the result changes. Okay, so this is the analysis how the vector addition is not same as the scalar addition. Okay. So this is the some concept that has to be known. I will not go into some more detail into scalar and vector because this is a separate chapter and I am discussing that much what will be useful for the discussion of the kinematics. I will not go to some extent more than it is needed. That separately I will take in other lectures or other classes. That chapter will come on scalar and vector differently, and there I will discuss few more topics on scalar vector that has to be needed for particularly the scalar vector. Okay, now as I have given example of electric current, pressure also have some you can say also have direction, because pressure exerted, that is a directional, because pressure is connecting downward, connecting sidewards or upward. So pressure also have direction, but pressure is not a vector quantity. Pressure is a scalar quantity. Okay. Why you can say, because if I consider a balloon and there is gas inside, the pressure is being exerted in every direction. Okay, so now any of there are chances where the pressure on this wall and in this wall are equal. So if it is equal and opposite, so there has to be they has to be nullify each other. If it is a vector, then slowly this balloon must have come down, but it is not happening. This is not nullifying each other. So effect of pressure is not a vector, it is a scalar. You cannot cannot treat it as vector. Okay, so basically the electric current and pressure is a another kind of physical quantity that is being taught in other subjects. Those are called basically tensor. Okay, those are tensor quantity you can say. Okay, so that is not I am going to cover it. So the next subject, there are some example of scalar and vector. Scalar and vector, few of already I have discussed. So in scalar the term will come distance. So distance will not depend on direction, but the displacement will be depending on direction. So for example, if I say the 2 points, there may be several paths to move and reach this point. Let's say this is point A, this is B. The shortest of it is the straight line distance, which I call, if let's say this is A path, B path, C path, D path. So C is the displacement and any other are the distance. Okay, so when I will say the C is the displacement, so displacement is has a direction from A to B, although everybody has his direction, but if you follow this curved path, the direction always changing its route, but it is a straight line, direction doesn't change, and it will move from the start point to finish point following the same straight path. So that displacement is always a directional quantity, and it is defined direction. So this is a vector quantity. Now see, one more thing you can distinguish. If I denote it as d, is the small d, so you can see the capital D always greater than small d, because the shortest is called the d and any other is more than the shortest distance. So this equation will implies there. Now the next thing that will come is speed, that I learned. Here it will come velocity. Speed is nothing but the distance traveled by time. This is nothing but the displacement by time. So now if I take the same example, A and B points, this any path followed will give you the speed, because this will be distance traversed, and if there is a definite start and end point, the straight distance will be considered d. So that will give you, for the same time, that will give you your velocity. So velocity always have direction as displacement have directions. Okay. So this will be like that. Displacement is time. Time is scalar. Temperature is scalar. Energy is a scalar. Work is scalar. Frequency is scalar. So these are the some kind. Here one more terms will come. Acceleration is also vector, because acceleration is nothing but the change in velocity upon time, or rate of change of velocity, you can say rate of change of velocity. So as velocity has direction, so acceleration must have a direction. Okay. Now here that one term, that work done is nothing but force into displacement. So force into displacement both are vector, but still work done is scalar, because this kind of calculation, there are two things. When the two vectors coming in picture, there are two concepts. I will discuss it now. As you know, there are scalar and vector, so there may be possibilities that they has to be calculated together sometime. So when a scalar is multiplied with a vector, it's always a vector. How? Let's say 3 multiplied by with any vector, as it is numerical, so that will give you 3 vector. Now this could be your time, let's say scalar. This is your velocity. Okay, so time into velocity will give you displacement. So any numeric multiplied any scalar means time with a velocity v, a velocity will give you a vector that is also a vector, that is displacement. So this is an example where scalar into vector will give you vector. Now while we doing vector into vector, there are two multiplication method. One is your dot method. If any two vectors multiply with a dot method, the resultant will be the mod of this. Mod means the any vectors, mod means the only the numerical value of that. So if I say 3 Newton, so that means the mod of it will be, the mod of this vector will be 3 only. Okay, 3 Newton, the vector will be 3 Newton east. If I say So the mod of this 3 Newton, east will move out, so the only the value will be 3 Newton. Okay, this will not define any direction. So like that. Here the vector, if it is denoted by V bar, then V bar mod will be the vector, so that the dot product of that will be denoted by V and V cos theta. And there are another product, that is cross product. If we do cross product, that V vector and V vector, that will be same and will be accompanied with a sin theta. So theta is the, if the two vectors are there, similar vectors, so theta is the angle between those vectors. So accordingly, if it is a dot product, that will give you cos theta. So as I am describing, that work done is nothing but the force and multiplication. So this case, it will be force into displacement. So just for the knowledge of this, that will be a very that will be taught in higher classes 11 and 12. But as of now, just remember, when there is a dot product between any vectors, so that means when it will come dot product, there, if the vectors are acting in a linear path in a same direction, that means two vectors, the direction of the vectors are same as the resultant. So whatever be the resultant of the cumulative action of these vectors, the resultant also follow the same direction. If the direction is not along with the two vectors, let's say this is vector A, this is vector V, and if it is the resultant is also following the same direction, so this will be calculated by vector A, vector V dot product. And the direction, if it is changing any direction, then resultant, so then this vector, the resultant will be calculated by cross product. So just remember this fact. This will be enough for now. So further, so as what I was told, the energy is nothing but the capacity of doing work, so that is also scalar. And other quantity, time doesn't need any direction. Temperature for anything, you can if I say that we having a fever of 101 or 102, that needs only the unit 100. What is that? Fahrenheit, centigrade, and all that. For body temperature, this must be a Fahrenheit, so it cannot need to describe direction. Okay, so on that basis, we can say that also a scalar, not the vector. So now the representation. Now we'll talk the representation of a scalar. If I say, so scalar only represented by the letter, any letter A. Just like if I take the actual example, mass is denoted by only m. Okay, so scalar representation of the mass, whereas the vector is represented with bold letter, or a letter which is not bold, a thin, and a arrow on head, that also a representation of a vector. And the value of a vector is represented, by these two parallel lines. This is called mod. So mod of A, or sometimes with simple A, nothing followed by this, also can be used somewhere. So if you see this letter, this also denotes the value of that vector A. Okay, so this is the notation of vectors. Now so already told, for vector representation, when we will represent vectors, that will be represented by an arrow, and this arrow has specific characteristic. This is called the tail of the vector, this is called the head of the vector, and the length denotes the magnitude of the vector. So in graphical representation, if I say that the magnitude is this one, so definitely it must have some proportion, because that length will measure with the scale. Scale doesn't have any other mark other than millimeter or centimeter. So either we have to calculate the proportionate value of that vectors. Let's say if I say 5 Newton, 5 Newton meter you can say. So that 5 Newton meter, 1 centimeter, if I assume is 1 Newton meter. So if a vector is of 5, you can say 5 centimeter in length, let's say it is 5 centimeter length. So this will denote 5 Newton meter. Here I will say that the proportionate value of 1 Newton meter is 1 centimeter. Now the similar vectors, if I have to denote with this proportion, let's say 10 Newton meter, so then this line length will be of 10 centimeter. Okay, and if it is said to be in east, and it also should be said to be in east, then arrowhead would be on the east direction. Otherwise, if it is said to be west, then arrowhead, although the dimension will be of 10 centimeter, the arrowhead will be on the opposite direction. So these are the notations to represent any vector. Okay. Now I will come to the direction of the vector. Direction of vector. As because scalar doesn't need any direction, so I will not discuss on that. So we know the universal acceptance of the system is n, this way east, this is west, this will be south. Now let's say any vector, this one which is exactly 45 degree with east, is the direction of this vector is northeast. Now it is, if it is 45 degree with any of this 45 degree, so this is called northwest, and that of this way it will be 45 degree of either side, it is southwest. This is cumulative direction I am saying, and this way it will be southeast. Okay, so this is the standard one where the angle is 45 degree. Now let's say some condition arises where this angle is not 45 degree or any angle. So how do you represent that one? Let's say this vector have made 30 degree with east. Then how will you say the direction? This is west, this is south. So we can say the vector is 30 degree north. That means the vector is started moving from 0 of east, slowly moving towards north, because the anti-clockwise will always measure the angle of the vector anti-clockwise to the east. That means if I consider it is a positive x, so we always consider the anti-clockwise angle with the positive x, that is east. So that when moves and going towards what side will be read as 30 degree north of east. So from where it has started, that will follow last, and wherever it is going, it will come first. So and the angle will be read first, angle towards which is moving north, from where it is moving, that one. Now let's say if I draw this one and I say this is 60, so this could be read as it is started from north moving towards west. So and 60 degree is mentioned with north only, so this will be 60 degree moving towards west. So west will come here of north. Okay, let's say this only change to either means instead of taking a 60 degree, I mentioned the angle of 20 degree here. So what would be the direction of this vector? Now this vector mentioned with the 20 degree here, so this will be 20 degree. Now I will assume this is moving towards north, so towards north means 20 degree north of west. Okay, so this will be the representation of our vector according to the side it is moving. So the angle which is mentioned here has to be read like that. Okay, so I think you have understood this. So you assume that east is the positive x, and similarly this is negative x, this is y positive, this is y negative. So similarly you can remember that also, any angle of a vector always to be measured from positive x-axis in anti-clockwise direction. So vector angle has to be measured from positive x in anti-clockwise direction. Okay. Now another thing is that yes, the angle between two vectors, how do I denote that angle? No, before than that, I will discuss some. So direction I think you understood. Now some important you can say point related to vector. Point related to vector. These are the point which is universally accepted for a vector to describe any problem regarding vector. Okay, so this has to be a standard one, it cannot be deviated. So first one is rotating any vector by 360 degree or pi radian or its multiple will not change the vector. Okay, so how it is that? Let me think. This is, now I am assuming this is one vector which is rotating along the axis. Now it has started from this axis x. Now it has started moving. So it is moved up to 90, then after 90 to 180, then 180 to 270, pivoting at 0, then after 90 again and coming to this. So this total angle moved by is 360. Now see, when it is moving 360, it is overlapping from where it has started. So we cannot distinguish those two vectors if it is overlap with the same axis with the same magnitude, because when vector is rotating itself, the magnitude will not change, it will be same, and when it is merging to the same where it is started, so that means direction is also same, so vector will not change its value. So that means magnitude wise and direction wise it will be same. Okay. The second rule or the point of the acceptance is second one, a vector can be shifted parallelly without any change. So That means to say, if a vector is parallelly shifted by a distance keeping the same magnitude and direction, the vector won't change. It is acceptable. That means, let's say a vector is drawn here. Now I need it to transfer at some distance to match the requirement of the problem. So I can shift it parallelly to a distance. Let's say this is 2 centimeter, and here I am drawing the same vector. Let's say vector A, which is having dimension, let's say x, and let's say xa, xa. So this will also be xa if it is the magnitude and direction is same. So this the same vector can be said here also, or this can be shifted backwards also. That will not change. This can be shifted this way, this can be forwarded, or anywhere parallel to this. If the magnitude and direction keep same, that vector will not change its value. So it is acceptable to shift any vector parallelly if it is required. So this is the second acceptance. The third acceptance is that the angle between, this is most important, the angle between two vectors is smaller of the two angles when matches tail by tail. Okay, so that means this I will describe in next video, because this needs some time, and further with this some more related subjects are there, so that will take time. So I will stop it here. In next video I will continue from this point. Okay, thank you for now.